Hi, I'm Joe James. This is my sixth video in my series on solving quadratic equations. So we're going to start this problem by applying FOIL to this x plus 3, x plus 3. So let's multiply these out. So first gives us x times x, which is x squared. Outer gives us a 3x. Inner gives us 3x also. And last gives us 3 times 3, that's 9. And when we combine like terms here, well, we have two 3x terms. So we get x squared plus 6x plus 9. So here we applied FOIL to this, and we got x squared plus 6x plus 9. This is what's called a perfect square. And here's why it's called a perfect square, because both of these two terms here, these two binomials, are identical, x plus 3 and x plus 3. In fact, you could rewrite this as x plus 3 quantity squared, because we have x plus 3 times x plus 3, which is exactly what the definition of squared is, a number times itself. And here we have a binomial times itself. So this is called a perfect square. And when we have a perfect square, you can see that if we take the square root of the 9, which is 3, and then we double it, we get this 6. So in other words, the c, or the 9, is equal to b over 2 quantity squared, right? Or 6 over 2, 3 squared. And we'll see that in some problems, and it's going to come up later on as well, so it's important to note that. In this problem, we have x minus 3, x minus 3. We're going to go ahead and multiply this out. First, let's note that this is equal to x minus 3 quantity squared. So this is also a perfect square, however, with a negative 3 instead of a positive 3. And when we multiply this out, we get first gives us x squared, and then the outside term gives us negative 3x. Inside term also gives us negative 3x. And the product of the two last terms, negative 3 times negative 3, gives us a positive 9. And when we combine like terms, we get x squared minus 6x plus 9. And we note again that we can take this 6, we can divide it by 2, we can take b over 2 quantity squared, and it will still equal c, right? Negative 6 divided by 2 is negative 3. Squared is a positive 9, which is what c is. So that still holds true, this little equation here. Another note here, x minus 3, if we wanted to go ahead and solve this for values of x that satisfy this equation, if we set it equal to 0, x minus 3 equals 0, and then solve for values of x, well, we could set x minus 3 equals 0, which is one of these binomials, and we add 3 to both sides, and we get x equals 3. So in the negative case, where x minus 3 quantity squared is equal to 0, there's only one solution, and it's x equals 3, positive 3, because both of these are going to give us the same result. So there's only one solution. So in the two different cases we just looked at, we see x squared plus 6x plus 9 equals x plus 3 times x plus 3, which is x plus 3 quantity squared. That's called a perfect square because of this. And then in the negative case, you see that it's exactly the same equation except that the b value is negative. And if the b value is negative, then when we factor it, we're going to get a negative value for both of those two factor terms, those two binomials. And when we write that in perfect square notation, x minus 3 quantity squared. So we see we have a negative 3 here because b is negative. Now let's go ahead and solve one of these perfect squares by factoring it. So we have x squared plus 14x plus 49. Our little equation is this: b over 2 quantity squared equals c. And if this holds true, then it's a perfect square. So if we take 14 over 2 and we square that, that's actually 7, right? 7 squared equals 49. So since this holds true, this is actually a perfect square, and we can rewrite this as x, is it plus or minus? Well, let's see, there's a positive b, so it's going to be plus 7 quantity squared equals 0. And then if we find the solutions for that, again, there's only one solution, and it's going to be a negative 7, because if we have x plus 7 equals 0, and we subtract 7 on both sides, we get x equals negative 7 is our solution to that perfect square. So our general formula looks like this. If x squared plus 2nx plus n squared is a perfect square trinomial, then look, x squared plus 2nx plus n squared equals x plus n quantity squared. So that's the generalized formula. And I wrote out specific examples here of both having a positive n, which we just saw, right, positive 3, and a negative 3. So this is our general equation for the perfect square trinomials. I hope this video was helpful for you. If so, please click the like button and subscribe to my channel. I'm Joe James. Thanks for watching.